Welcome back to another AMC video. Today we'll be covering problem number 25 from the 2023 exam. So let's dive into it. 15 integers, A1 all the way through A15, are arranged in order on a number line. Right? Number line. The integers are equally spaced and have the property that A1 is going to be between 1 and 10, A2 is going to be between 13 and 20, and A15 is going to be between 241 and 250. What is the sum of digits of A14? Okay, so basically we have to find A14 in this problem, or the 14th term of the sequence. But how can we do this? Well, see, in any given sequence, or especially in this sequence, we don't have much really information. So the first thing we should do is try to find the common difference. But how do we know there is a common difference? Well, it says the integers are equally spaced. So once we realize this key piece of information, this is an arithmetic sequence where all the digits or integers / terms are equally spaced. So now we can rewrite this as, so let's say A1 will just be A1. But A2 can be A1 plus D, D being the common difference. And then A3 will just be A1 again, but plus 2D. Now why does this work? It's because each term you're adding the common difference once, and then you're adding it again. So this goes all the way until A14 will be A13. Oh, sorry, not A13. A1 plus 13D. And finally, A15 will be A1 plus 14D. So now what can we do? Well, our goal should be to find the last term because it's the closest to A14 and they give us a range of possible numbers for it. And it can only be 10 numbers between 241 and 250. And here's the key realization here. It says integers in the problem. Now why is this important? First of all, this lets us know that it's a diaphantine equation, which basically means all the possible answers will be integers. So now what can we do with this piece of information? Well, here we can realize that A15 is nothing but a factor of 14, or multiple of 14, plus that A1. So if we just get rid of that A1, we can easily find the common difference by using this factor rule. So how would we do this? Well, if we needed to subtract A1 from this A15, we just need to find the minimum and maximum possible values for A15. So what would that be? Now, the maximum value would be the max minus the min of A1. So that would be 249. Right? And the minimum would be the opposite, to 241 minus 241 minus 10, which is going to be 231. Let's rewrite that a bit neater. Okay, so the A15 now, or basically the common difference in A15, can be between 231 and 249. So, first of all, we can just find some multiples of 14 that are between these ranges. So, what are some? Let's just try out some numbers. So, let's say 231 divided by 14 to get a rough idea. That's going to be 1, 9, let's say 7, oh no, not 7, 6, 84. So we get a remainder of 7. So we know that it has to be at least 17 because the minimum is 16. But the common difference has to be an integer because look, it says integer here as well. So that means it has to be at least 17. Okay, so 17 is one possible option. Let's list it here for the common difference. These are common differences. 17. What about 18? Would 18 work? Let's try that out. 18 times 14. 252. No, that would not work because it's greater than 249. So we already found our... Oops. Looks like I erased that. 1 second. Okay. So we already found our common difference. It's 17 because it's the thing that we can plug in to make sure it's within this range of numbers. And that's because we removed A1 from A15. So now that we know our common difference, we just need to find what our first term is now. First term is. So that way we can get the actual number of our last term and first term at the same time. So difference is 17. Okay. So we know that A15 has to be between 241 and 250, right? So and we multiply by 14. So first of all, what is 14 times 17? It's 238, right? So what are the possible values we can add from A1 to get a number that's within these ranges, right? So, okay, let's list them out. So can we add 1? Can A1 be 1? Well, no, it can't. Because 17 times 14, like we discussed, is 238, right? So 238 plus 1, that's 239, but that doesn't fit in this range. Same for A1 equals 2. That also does not work, right? Because then it would only be 240. What about A1 equals 3? Yes, that does work. Because then we get that, then it would be 241. 243. 3. But it can also be 4. So how do we figure out if it's 3, 4, 5, or 6, or any other values that work? Well, here's where A2 comes in. Now, A2 is nothing but A1 plus D. We already got that, it's 17. So if we know that A1 is going to be 3, we can plug in 3 here. 3 plus 17, that's 20, and that does work. But anything above 3 wouldn't work because it would be more than 20. So our A1 is definitely 3. Just like that, we found A1. A1 is 3. And now we can directly find A14. We don't even need A15 anymore. So what is A14? It's A1 plus 13D. So A1 is going to be 3 plus 13 times 17. What's that? 13 times 17. That's 221 plus 3, which is going to be 224. And that is our final answer. That is what A14 is. Now we just need to add the digits. So let's write one more thing here. 224. So 2 plus 2, that's going to be 4. Plus 4, that is going to be 8, which is our final answer for this problem, which is A. So I hope you guys enjoyed this AMC problem, and it was pretty tricky, right? Because we didn't really get much numbers, but by noticing key information such as integers and equally spaced, we can rewrite this as a diaphantine equation, and we can use this common difference to find the possible terms within these given ranges to narrow it down to just one term in each category to figure out A of 14. So smash that like button so I can keep continuing this channel, and I'll see you in the next one.